The Life Cycle of Stars by Madison Bricker. The first step in a star's life is the nebula stage. A nebula is a large cloud of gas and dust. As the gas and dust put gravitational force on one another, the nebula contracts and begins to spin. As the speed increases, the condensed gas and dust heats up to eventually form a protostar. At this stage, the star is unable to begin fusion, as it is not hot enough yet. And since the nebula is not a star yet, it cannot be graphed on the HR diagram. The second step in a star's life is the protostar stage. The nebula continues to condense and compress due to gravitational forces. The continuation of these forces causes the core to continue heating up, and this is the stage when fusion begins. A star is born due to all of the pressure, and the birth causes a massive release in energy outwards into the universe. This is where I graphed the protostar on the diagram because it is very young, very bright, and very small. Normally. This is fusion explained. Fusion is when you combine two or more atoms to create a new atom. And this form of fusion energy is produced by merging hydrogen into helium. Mass is lost in this reaction, though a large amount of it. The mass lost is transformed into great amounts of energy. And the process for fusion for stars is 4 hydrogen atoms combined to make 1 helium atom. And remember, the mass loss is transformed into energy, which fuels the star. The third step in a young star's life, the third step in a star's life is the young star stage. Early in life, the heat created from fusion within the core creates the star's gravitational force field. After a very long time, all the hydrogen in the core is eventually used up in fusion. When this happens, the balance that the star originally had just stops existing because of pressure and gravitational forces. The core begins to shrivel, and the temperatures begin to decrease as well. The outer layers of the star swell and cool down, although it is still very, very hot compared to the life on Earth. And in the HR diagram, I graphed it a little bit further down than the protostar because it's a little bit less bright and it's a little bit older than a protostar. The fourth step for low-mass stars is essentially the death stage. Helium in the core fuses to carbon. Because of gravitational forces, the core caves in on itself. The outer layers of the star are shoved off, and they form a planetary nebula around the star. Without the outermost layers anymore, the core becomes a tiny white dwarf. The white dwarf eventually runs out of energy and dies off into a black dwarf. Although there are currently no black dwarfs in the universe because it's simply not old enough for one to form yet. And on the HR diagram, I graphed it in the bottom left corner because they are very small and very hot and not very bright. The fourth step for high mass stars is not the stage where they die. Evolution happens quicker and is more violent for high mass stars. When fusion stops, the red giant grows into a supergiant. The core condenses and heats up, forming iron. The iron eventually explodes once it has crushed enough in the core. This explosion creates a giant shockwave and forms a supernova. And in the HR diagram, I graphed supergiants and red giants because they are very cool but very bright and very big. And the reason they are very bright is because they are very big. And the fifth step for high mass stars, and this is high mass stars only because low mass stars are already dead. After the explosion, all that is left is a neutron star, which is the smallest and densest star believed to exist at the moment. And if the star is 3 times larger than the sun, it will eventually become a black hole. And the only star I can graph on the HR diagram is the neutron star because black holes are simply not stars. They are graphed in the very lower left corner because they are not very bright. They are very, very, very dim and very small. And yeah. Thank you for watching.